STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Dr. Hashima Hassan.
Hello and welcome to this week's NASA STEM Stars. Each week we connect with subject matter experts that work at NASA and learn about their STEM career and their education and personal interests. At the end of today's episode, I will challenge you to complete your own mission and share your work with us. I'm Jen Hudgens and I'm coming to you from NASA's Kennedy Space Center. Today's mission plan will be to meet our guest and explore her career. I want to encourage you to ask your questions in the chat box to be answered by our guest. So let's get started. Today's guest is Dr. Hashima Hassan, and she comes to us from NASA headquarters in Washington, D.C. Welcome, Dr. Hassan. Thanks for joining us today.
Hello, Jen. Thank you for inviting me.
I'm so excited for you to share your work with the Webb Telescope and tell us a little bit more about yourself. So let's just dive right in. Why don't you tell us more personally about yourself and what you enjoy doing?
Well, I'm a program scientist at NASA headquarters, and in my time there, I've managed more than a dozen missions. But these days, one of the missions, most exciting one I'm working on is the Webb Space Telescope. And in my private time, my hobbies are reading, traveling, and cooking. And in these COVID days, I've experimented with a lot of Indian spices and come up with new recipes. And I love exploring new places, meeting new people. And one of the most memorable journeys I did was a train journey across the United States from San Diego and the West Coast of California to Washington, D.C. And my best activities are playing with my grandchildren.
Wow, I bet that was a beautiful trip across the country.
Yeah, it was fascinating, totally fascinating.
Can you tell us a little bit about how you became interested in astronomy, maybe when you were younger?
Yeah, sure. So if you could go to my first slide, I grew up in India at a time when the Indian skies were dark and clear with no light pollution or industrial pollution. And there were times that we could even see the Milky Way. And I used to sleep out at night in the hot summer nights and stare at the cloud, stare at the sky, at the stars and moon. And my love with space started when the first space satellite, Sputnik, was launched in 1957. And my grandmother got the whole family, right down to my 2-year-old sister, to stand in the backyard of our home in Lucknow and watch Sputnik go past like a moving star in the skies of Lucknow. And just to give you an idea where Lucknow is, I have a map of India on the left, and Lucknow is ringed with red. And there are two more cities I'll mention as we go along. One is Aligarh, which is about 200 miles northwest of Lucknow, and then two on the west coast, Mumbai and Pune. So if you could go to the next slide. Then on the picture on the left is that of my elementary school, Loreto Convent Girls School, which was operated by Roman Catholic Irish nuns who didn't believe in teaching science to the girls except for botany. But I was very fortunate that when I was in the 9th grade, we got a new headmistress, and this nun had just come back from the United States with this revolutionary idea to teach science to the girls. And so my science education started. I went for undergraduate to Lucknow University. I wanted to do astronomy, but my sisters and I were not allowed out of the house unescorted, so there was no question of going for observation that night. So I graduated with what was called pure sciences, physics, chemistry, and math, and then I went on for my postgraduate degree in nuclear physics to Aligarh Muslim University. And from there, I won a scholarship to the University of Oxford. And on the right-hand side, you'll see my college, Lady Margaret Hall, and I got a doctorate in theoretical nuclear physics.
I can say those buildings are gorgeous. I love looking at those pictures. So how did you get from Oxford? Where did you go after Oxford? Because clearly you're working at Washington, D.C. now. So tell me a little bit about your path from India and England all the way to America.
Okay, so from Oxford, I started what I thought would be a traditional academic career, and I went for a postdoc to Tata Institute of Fundamental Research in Bombay, which is the building on the top left. From there, I got a faculty position in the physics department at the University of Pune, which is the building on the right, and that is a historical building. It used to be the summer residence of the governor of Bombay, and it was given to Pune University after independence. And while I was in Pune, I got married, and I followed my new husband across the Atlantic to the United States. And you see on the left-hand side, he was on the lower left-hand side, he was at that time in North Carolina. So I got tutor position at Duke University in Durham, North Carolina. And while there, I applied for a National Research Council fellowship to the US EPA to study air pollution in Denver, Colorado. And then I had my first baby, and that's another story for another time. And then we crossed the Atlantic again. And so if you could go to the next slide, you'll see that on the upper left-hand side corner is the Bhabha Atomic Research Center, because I was again in Bombay, so I came back to nuclear physics. And then 1985 was a big change. We came back to the US, and this time I had two toddler boys. If you see the picture on the right-hand side, it was a real challenge raising these two little ones. As well as trying to do a full-time job. But I did get a full-time job at Space Telescope Science Institute in Baltimore to develop the simulation software for the Hubble Space Telescope, which was to be launched soon, and its science instruments. And
so we've had a couple questions come in. Can we ask what place was your favorite? So of all of those places that you just told us about, did you have a favorite?
Well, of course, Lucknow University. I mean, Lucknow is my hometown, so that would always be my favorite. But I loved Pune. It was just, or it's called Pune now. It was just a wonderful place to be in.
Another question, what were the biggest space accomplishments during your time studying? And how do they compare to what Webb will do? So we can talk about Webb in a minute, but as far as your studying time and your early career, did you have any big space accomplishments?
Yeah, in my early career, I don't think any of these space telescopes and astronomy had been launched till then, because my early career started in 1976, which was a long time ago, long before the Hubble or any of them. So I would say not till I joined Space Telescope Science Institute.
So after the next slide, you actually address some work that you did on Hubble. So maybe we can share that next slide and you can talk to this one.
Yeah, so as I said, I developed the software for the optics of the Hubble, and I didn't realize how important it would be after Hubble was launched, because we found an optical problem with the Hubble. And so I was responsible for keeping the Hubble in focus till we could analyze all the images and design a fix. So so I was appointed the telescope scientist, and for the 3 years when the first servicing mission happened in '93, and the fix was installed by the astronauts. And while there, I was also given research time. So I was able to do research in astronomy. And I published my first paper as a research astronomer in the Astrophysical Journal. And there I finally achieved my dream of being a research astronomer.
And I saw you had a small picture of Hubble there in case no one was familiar with what Hubble looks like. And we'll talk about the comparisons of Hubble and Webb in a minute. But can you tell us a little bit about how you became a citizen of the United States and then your journey to NASA from there?
Yeah, so we went through the usual process of applying for citizenship. We had to, be in residence for 5 years before you could apply. And so I got my citizenship in 1993. And in this picture you see on the left, I'm in my office at Space Telescope Science Institute, and my colleagues gave me a surprise celebration. They all stormed in with, all typical, as you can see over there, hot dogs and a Chevrolet car and a baseball and red balloons, and complete with a photographer. So, and it was an amazing experience. And then once I was a citizen, I felt that I can now start serving the US taxpayer. And I applied for a visiting scientist, senior scientist position at NASA headquarters, which I joined in 1994.
Okay, we have just a few more questions here. Were you interested in physics before the start of your career or when you started it? And do you think that becoming a scientist needs, well, I guess, intelligence or the skills maybe that are necessary if you want to become a physicist or scientist?
Yeah. So I wouldn't say I was, I really didn't know so much of, difference between physics and chemistry till I actually started doing it. But I found physics to be the most challenging of the three major subjects we did. I loved all of them, but I found physics the most challenging. And I just felt I had to do physics to try and understand what lies at the basis of everything in the universe. And so that's how I went into physics. And I think, first of all, most importantly, you need to have the passion and the curiosity to be a scientist. And if you have that, it may take you a little, it might require some people to work harder to get at it, but everyone can really be a scientist in their own way, because you're basically trying to understand how the universe works.
I think I'm in total agreement. Curiosity and the pursuit for answers.
Exactly.
So let's jump in and talk about some of your work with headquarters at NASA. What projects were you involved in?
Yeah, as I mentioned earlier, I was involved in more than a dozen projects, all of which I can't mention here. So I'm just going to mention three. So you see on the left-hand side, you've seen this picture a couple of times more in this presentation. I'm standing in front of the actual mirror of the Webb Space Telescope, which is inside the clean room at Goddard Space Flight Center when it was being put together over here in Maryland. And then in the middle, I'm in front of the Keck Observatory in Mauna Kea, Hawaii. It's a ground-based observatory, but NASA has a 1/6 partnership because with this, and I'm responsible for that because there are some ground-based observations need to be done to support our for strategic support of our science with our space telescopes. And then on the right-hand side at the bottom is an airborne observatory for infrared astronomy, which is where in which we have a telescope which was provided by the German space agency, with whom we have a partnership inside a 747. And on the top right-hand corner, I'm inside the observatory in the plane with a group of teachers who we call the Airborne Astronomy Ambassadors. And I'm also responsible for education and public outreach for astronomy. So you're seeing me here with the teachers. So there are a lot of different things we do as program scientists at headquarters.
We've had a student ask what project that you worked on or that you can discuss do you think had the greatest impact so far?
I would say definitely the Hubble Space Telescope. It's now been going on for 30 years, and it's made great discoveries of things we didn't even know of. And excuse me. And some of the research done by Hubble led to a Nobel Prize on dark energy, which Adam Rees was one of the astronomers who got the prize.
One of the students will also want to know what were some of the biggest challenges with Hubble. So I know when we were showing your papers, you had talked about the inability for Hubble to focus. So do you think that was your biggest challenge?
So that was the earliest challenge, was the optics problem, which we fixed with the servicing missions. But then it's got very old technology, and the instruments we had to change them out. So we've had 5 servicing missions so far, where we've changed out instruments, where we've fixed problems on Hubble, and so it's still going strong. It's 30 years old.
So your newest project is with the James Webb Space Telescope. So is the Webb Telescope intended on taking over Hubble's work, or is it going to be in conjunction with what Hubble does? Let's talk a little bit about the Webb Telescope.
Yes, so the Webb is considered as a successor of Hubble. As you'll see, as a comparison of the power of Webb, you can see on the inset on the top right-hand corner, you see the Webb mirror, which consists of hexagonal segments, and its diameter is 6.5 meters compared to 2.4 meters of the Hubble. So it has a much bigger light gathering power, and it's much more powerful than Hubble, and it operates in the infrared and can see way back in time to the from the time that the first stars and galaxies were formed. Now Hubble will still continue as long as it's in operation, but the work that Hubble and James Webb do are complementary. So they will complement each other's science. Hubble has instruments which observe in the visible and ultraviolet, and Webb does in the infrared. So we get a lot of complementary science and synergy between the two. I can't hear you. I can't hear you, Jennifer.
I'm sorry, that's okay. I was saying in the image there, the telescope looked quite large. Can you tell me, like, compare it to the size of something or to Hubble itself? How big is Webb?
Yeah, so the diameter of the Webb, I would say maybe about half the size of a school bus, but it is, as you can see, unlike the Hubble, it's not inside a tube, and it'll be at 1 million miles from Earth, but it has to be kept cold. So we have a sun shield below it, and the sun shield is the size of a tennis court. And you might wonder how something so big can be launched. So it's designed so that it all folds up. And if you go back to that slide, you'll see on the left-hand side where it's folded up and into the rocket. And I have a video. Yeah, you see on the left-hand side where the whole telescope is, and the spacecraft bus, the whole thing, and the sun shield are folded up, and so it will fit inside a rocket before it's launched.
That's quite impressive.
Very impressive.
And you have a video that you brought?
Right. I have a video which shows the actual telescope at Northrop Grumman being folded up. And so here it is. It's in the clean room facility at Northrop Grumman in California. And that's where the telescope was put together with the sun shield and the spacecraft bus. And here it's all being tested out. And here you see the mirror has been folded up, and here the sun shield has been folded up, and the whole thing is being put together so it can be put into the rocket. And then here it's now in its final folded position. And then there's I think after that there's right, it's showing more of the same thing. And here is a simulation of it being launched and how it'll open up after launch. So it's just a few seconds here, but it'll take a few weeks to actually open up.
A student wants to know, is the telescope going to be visible from Earth?
It's 1,000,000 miles away, so I definitely can't see it with a naked eye, but maybe with another telescope.
Well, is Hubble visible? Where is Hubble in relation to where Webb will be?
Hubble is about 300 miles from here.
Okay, and so, you said a million.
Yeah, but again, 1,000,000 is not as far away as the stars, so I think we should be able to see it. But certainly, you see the space station go by, you can see, but you have to be in the right place at the right time to be able to see them.
Yeah, students are interested in finding out when they can go out and look at the space station. There's actually a link that they can sign up for. It's at NASA's website called Spot the Station, and they can be alerted for when it's going to go over anywhere in the world. So that's pretty impressive too, to see those astronauts going by above their heads. Let's see. So can you tell us a little bit about the science of the Webb, what it's going to be doing once we deploy it?
Yeah, so the Webb Science themes, as we call them, is to see the first light when the stars started forming. And so after the Big Bang, there was a period of darkness when the electrons and protons were combining to form neutral hydrogen. And then once these hydrogens molecules started clumping together by gravity and forming clouds, that's when nuclear reactions started taking place and stars were born. And so we will be able to see the birth of stars. We'll start seeing protoplanetary systems and how planets were formed. We'll see how the stars were assembled together to form the earliest galaxies. And then we'll also be able to look for the origin of life. And the way we do it is that Webb has both cameras as well as an instrument called spectrographs, where you can look at the spectra of the various chemicals that are present. And from analyzing the spectra, you know what is actually contained in what on the objects that you're looking at. And so if we see signs of life would be like carbon and hydrogen molecules like methane and other molecules made with carbon and hydrogen, then there'll be we look at that as signs of life. So it's a very exciting program that we have in store for everyone.
We had some questions about images that are taken, and I know your next slide addresses the James Webb Telescope and how it's an infrared telescope. A student asked about Hubble's images. Is it true that they're black and white? And then maybe we can talk about your next slide as far as what Webb and the images we'll get from Webb.
Yeah, so here is two images actually from Hubble. And So the images that come both for Hubble and the Webb, they come as computer signals on your computer screen. And so in that sense, they are not colored, but but we give them colors depending on what chemicals they're made of and which filters they come through. So the image in the left is taken in the visible part of the spectrum. So because of that, the light of newborn stars behind these dust clouds doesn't come through. But on the right-hand side, there is an infrared camera also on Hubble, and you can see the stars forming, the stars which are forming there, you can see them through the dust. So it's exactly the same object, the Carina Nebula, but it looks very different in these two. I can't hear you. I can't hear you.
I was just saying that's very exciting. When do you expect to launch Webb and start getting these amazing images?
Yeah, so Webb is scheduled to be launched next year in October, but it'll take about 6 months before we start getting really good images. It takes a while to deploy things and then to test out everything. And to get the instruments ready to do science. So they will get images, engineering images, but science images, it takes a little bit of time to get them. So you'll have to be patient, but once you get them, they'll be amazing.
Well, I know we've been planning on this telescope for quite a while, and technology advances so quickly. So are you able to incorporate those changes in technology as Webb is getting built before you deploy it? Have you been able to upgrade anything?
The technology itself is so complex that we don't really upgrade things. But when we find that there are some problems with something and we have to fix them, then you may have to redesign some small parts of it, but not the entire design now.
Yeah, I see. Are you planning on observing anything closer to home within our own solar system?
Yeah, well, since you mentioned it, if you go to my last slide, I know you love Kuiper belt objects, Jen, so this one is especially for you. So these Kuiper belt objects are, you may consider them to be in the graveyard of the formation of our own solar system. And so they sort of circle around the solar system. And the astronomers are very interested in understanding these because they are the leftovers of the creation of our own solar system and of our planets. And by looking at these objects, we'll get to learn a little more about the solar nebula and the formation of the solar system. And these are mainly sort of ice and very cold. So you have to see them with an infrared instrument. And the spectrometer on Webb would be used to analyze the various chemicals on these Kuiper belt objects. And Webb will also be will be used to learn more about the planets in our own solar system. So really within our solar system, there's a lot it can do, and also within our own galaxy.
So I have a question. If students want to use data from Hubble or from Webb once it deploys, is there a repository of data that students can access and use?
Yes, NASA in fact stores all its data in publicly available archives, and the data for all our visible and ultraviolet missions as well as Webb is stored in the Mikulski Archive for Space Telescopes, MAST, which you see over here. It's at the Space Telescope Science Institute in Baltimore. And this archive was renamed after our senator from Maryland, Barbara Mikulski, who you see on the right-hand side. She's a big supporter of science. And with her are our two Nobel laureates, Dr. John Mather on the extreme left. He's the senior project scientist for Webb at Goddard Space Flight Center, and Dr. Adam Rees, who I've mentioned earlier. He's a professor at Johns Hopkins University as well as Space Telescope Science Institute. So there's data right there, right now, for you to analyze from all the missions. And for those of you who are too young to observe with the Webb now, the data will be there for you when you're ready to analyze it. So
perfect.
Just go ahead. Yeah.
Perfect. Well, we're almost out of time, believe it or not, Dr. Hassan. So I want to give the students their challenge and their mission for this week. And I actually found this activity on the James Webb Space Telescope website. Students can themselves calculate various sizes and scales of distant objects using this worksheet. And I'd love for them to share their work with us on social media at #NextGenSTEM. And I also want to encourage everyone to tune in next week for a NASA STEM Stars in Espanol on Wednesday at 2:30 p.m. Eastern, where we'll be talking about the Artemis program. And then we will see you again next year in January. So happy holidays from all of us. And I want to give you just another moment, Dr. Hassan, if you would like to express your wishes to our students and encourage them in their future endeavors.
Yeah, so definitely I'd say to the students, pursue your dreams with passion and determination, just as I did when I stared at those dark skies as a toddler. What were the odds of a girl child growing up in an India which had freshly got independence from 2 centuries of British colonial rule to become a program scientist at NASA headquarters? I was really fortunate to achieve what at that time seemed like an impossible dream. So there will be many obstacles in your path which you will need to overcome. I would say be open-minded, be innovative, don't be angry and don't get frustrated. Have faith in yourself, work hard, and don't give up. And to the NASA science enthusiasts out there, I'd say visit our NASA websites for information and activities for the young and old. Analyze data from NASA missions stored in our archives. Team up with researchers and become NASA citizen scientists. We have a rich citizen scientist program. And finally, I'd like to mention that the Science Mission Directorate has just released our 2021 calendar, both in English and Spanish. You can download it free. The link is available in the chat. So just go have fun and reach out for the stars.
I couldn't have expressed them any better than that, Dr. Hassan. Thank you so much for sharing your day with us. And we'll see you again next time, STEM fans.
Thank you. It's been a pleasure.